Dear students, now today we are going to talk about the quadratic form in tensor calculus. So let us look what do you mean by quadratic form? Either it is familiar with all of us, all the students they are from the school level they are studying the quadratic form. So let us revisit again the quadratic form. Uh, Now, if you remember a quadratic, a homogeneous polynomials is called a form, and a form of second degree in its variable is called quadratic form. Like this, if the function f of xy is equal to x square plus twice xy plus b square is variables x and y is a quadratic form. If the coefficient a, h, and b here, you may know it is a, h, and b. These are the coefficient do not vanish simultaneously. That is, they hold the condition a square plus h square plus b square is greater than 0. Then this form is called the quadratic form. Now you look at all the standard form, and you are knowing this. Okay, standard form y is equal to ax square plus bx plus c. The vertex form, the same equation may be written like this also. We may rewrite a and x minus h whole square plus k. This is also the vertex form of quadratic equation. And then for factored form, if you want to write the same expression into the form of this factors, then you can write a into x minus b into x minus q. Sometime in some books and some authors, some teachers, they use this a into x minus alpha and x minus beta. If alpha and beta are p and q are the distinct roots. Now, the second important fact in quadratic form is qx is equal to ax square. Then this is called the unary. Unary means ax square. If qxy is equal to ax square plus bxy plus cy square, then this is called binary. Now, in these days, these terms are very important. And if qxyz, that is ax square plus bxy plus cy square plus dyz plus ez square plus fxz, then that is called ternary. Okay, so this is the unary, binary, and ternary. Now, examples of some quadratic form, you may write y is equal to x power t. This is for transpose a matrix form into x. So this may be written like this. Okay, y is equal to ax power t ax. This may also be written like this, and y is equal to x power t ax is equal to, this is the standard form, a1 x1 square plus a2 x2 square and so on up to an xn square. So this standard form means a can be many for a particular quadratic form. To make it unique, it is customary to write into the form of matrix notation. Okay. So this is about the quadratic form. Now here I want for the viewers, for my students, if they should do some practice of this problem. So this you may treat as assignment or for practice. You let x is equal to, this is the matrix x1, x2, x3 belongs in R and consider the polynomial px is equal to x1 square plus x2 square minus 3x3 square plus 2x1 x2 plus 6x1 x3 minus 6 x2 x3. Then show that P is a quadratic form. You have to show that this P is a quadratic form. Mathematically, you have to prove. And second question is, we find a coordinate transformation diagonalizing the quadratic form above for the above problems. So these are the two problems here. And here, this is one also three sub problems, smaller problem. You write each of the following using the summation convention. So yesterday we discussed about the summation convention. So first, dx bar k divided by dt is equal to del x bar k del x1 dx1 plus del x bar k del x2 dx2 plus del x bar k del x3 dx3. Okay, now similarly this problem, so the summation form of this problem, and now third problem is this problem. So we want all these three problems from you. You have to write and practice these three problems. Okay, so you do the practice and you tell me, just do the practice for you about these three problems. Then so that your basic of the tensor you may be able to study the tensor as a whole. Now, just if you want to connect with the matrices, so here is the connection with the matrices. You know this: Ex square plus 2bxy plus cy square. You may write xy, another matrix AB, AB and BC, and third matrix is xy. Okay, like this. So quadratic form correspond with symmetric matrices. Okay, if you want to redefine the quadratic form, then here you may redefine like this. A quadratic form on this is a function q defined on this, whose value of at a vector x in this is a symbolic notation of quadratic form, can be computed by an expression of the form qx is equal to x power t, means transpose of x, a into x, where A is a n cross n symmetric matrix. The matrix A is called the matrix of the quadratic form. Okay, so here this is the way how to define. If you classifying quadratic form, then it look like this. A quadratic form Q is positive definite if Qx is greater than 0 for every x non-negative x. Okay, or for every x non-zero x, and a negative definite if Qx is less than 0 for every non-zero x, and indefinite if Qx assume both positive and negative values. Also, Q is said to be positive semi-definite if Qx is greater than or equal to 0 for every x, and negative semi-definite if Qx is less than or equal to 0 for all x. If you look and differentiate here, so this graph is clear, provide you the clear picture. Positive discriminant if A, the value of A is positive and the discriminant is negative, then graph will be like this. Means this is called as positive definite. This is called positive definite. If the value of A is positive and discriminant is 0, then this is called positive indefinite. Positive indefinite. Okay. If the value of A is positive and discriminant is also positive, then this is called positive indefinite. Positive indefinite. If the value of A is negative and discriminant is negative, then this is called negative definite. And if the value of A is negative and the discriminant is 0, then this is called negative indefinite. Okay. So in this way, you can look all the terms. Thank you very much. Thank you.